So for the first figure it out problem in chapter 11, we have Squeaky Clean and Biobase. They produce chlorine for swimming pools. Their inverse demand function is P equals 32 minus 2Q, and their marginal cost is a constant 16. First part asks, if the two firms collude, splitting the work and profit evenly, how much will each provide, at what price, and what's their profit? So to start this question, we first have to remember our golden equation: marginal revenue equals marginal cost. Remember that we have our marginal revenue equation, which is marginal revenue equals A minus 2B Q. And so from our inverse demand curve, we plug those values in. We get 32 minus 4Q for our marginal revenue. Our marginal cost is given at 16. So 4Q equals 16 and Q equals 4. So we found the market production. Now we have to find the price. We can just plug that Q into the inverse demand curve. So P equals 32 minus 2 times Q, or P equals 32 minus 2 times 4, and so P equals 24. Okay, last step for this part, we have to find the profit. The profit for both of these firms, for both Squeaky Clean and even, so we say 1/2 times P minus C times Q. Okay, so we plug in, emphasize again that 1/2 since they're splitting it evenly, and we're going to plug in our price and cost, so 24 minus 16 times 4. And so 1/2 times 8 times 4 will be our profit. And so our profit for both Squeaky Clean and Biobase, since they're colluding, will be 16. So for the next part, it asks, does Squeaky Clean have an incentive to cheat by producing more units of output? So let's assume that they produce one more unit of output. That is, the market Q goes from 4 that we solved in the previous part to 5, meaning since they're splitting evenly, Squeaky Clean is producing 3 units and Biobase is still producing 2. So we plug that 5, the total market quantity, into our inverse demand curve, and we get a P of 22. So the price is lower. Let's plug that price into Squeaky Clean's profit function. That's P minus the marginal cost times 3. Careful, it's 3, because Squeaky Clean is producing 1 more unit itself. They were producing 2 before. Their profit now is 18. So that 18 is more than the previous profit of 60. So yes, Squeaky Clean does have an incentive to cheat in this case. And the question asks, does Squeaky Clean's decision to cheat affect Biobase's profit? So we have our market quantity, we have our market price, Now we need to plug in those new values into BioBase's profit function. So profit for BioBase is still price minus cost times quantity, but we have the new lower price, so it's 22 minus 16 times 2. BioBase's quantity doesn't change, only Squeaky Clean is cheating. So the profit for BioBase is 12. They were making a profit of 16 before, but when Squeaky Clean decides to cheat, BioBase ends up with a lower profit. And for the last part, it asks, if each of the firms produce 2 more units, what happens? Excuse me, if each of the firms produce 1 more unit, what happens? So now there are 6 units being produced, because we're talking about relative to A. We also want to know if Squeaky Clean still cheats. So we start back at our inverse demand curve. We plug in the 6 units for Q. So 32 minus 2 times 6. Each firm is producing 1 additional unit, so we go from a quantity of 4 to a quantity of 6. So the new market price is 20. Let's go into Squeaky Clean's profit function. So Squeaky Clean, we plug in that 20, their marginal cost, and multiply it. 1/2, because they're splitting it evenly. We're keeping it relative to the part A, so we have to divide the profits in half and multiply by the market quantity. So we have 1/2 times the new market price, which is 20, minus the constant marginal cost times the market quantity. They're splitting the profit evenly, so profit for Squeaky Clean is equal to the profit for BioBase, and that profit is 12. And so when they both produce more units, they both produce 1 more unit, both firms are worse off. Now for the last bit, does Squeaky Clean have an incentive to cheat? So let's imagine again that they produce 1 additional unit. So they were producing 3 units, now they're producing 4 units. So the market quantity being produced ends up changing. We have 32 minus 2 times 7, because now Squeaky Clean is producing 4 units and BioBase is producing 3. So the market price is 18. The profit for Squeaky Clean, the equation remains the same, but now we're plugging in 18 minus 16 times the quantity, which in this case is 4. And so Squeaky Clean's profit is 8. So that profit is actually lower than the colluding profit earlier in this part of the problem. So Squeaky Clean does not have an incentive to cheat.